Hi everyone, in this video you have to find some limits using trigonometric identities. So in part A we have limit 1 minus 2 cosine x plus cosine 2x divided by x squared when x goes to 0. So as you know, you have to rewrite cosine 2x using this identity. So you have to write it as 2 cosine squared x minus 1. Limit 1 minus 2 cosine x plus 2 cosine squared x minus 1 divided by x squared when x goes to 0. Now you have to simplify it by cancel 1 with negative 1, and you have to take the greatest common factor in numerator, which is negative 2 cosine x. So we have limit negative 2 cosine x multiplied by 1 minus cosine x divided by x squared when x goes to 0. Then, since we have the term 1 for the quantity 1 minus cosine x, you have to use the conjugate strategy to find this limit. So you have to multiply it by the conjugate of 1 minus cosine x. And the conjugate of 1 minus cosine x is 1 plus cosine x. And if you multiply 1 minus cosine x by its conjugate, it will be the first one square, which is 1 square, minus the second term square, which is cosine square x. And we have an identity that says 1 minus cosine squared x equals to sine squared x. So pay attention the illustration here. So multiply by 1 plus cosine x up and down, so in numerator you will get limit negative 2 cosine x, and this quantity equals to sine squared x divided by x squared multiplied by 1 plus cosine x when x goes to 0. Now you can split this limit. You will get negative 2 cosine x divided by 1 plus cosine x when x goes to 0 multiplied by limit sine squared x divided by x squared, and we can write it as sine x over x all squared when x goes to 0. For the first limit you have to use the direct substitution, and you will get negative 2 cosine 0, which is negative 2, divided by 1 plus cosine 0, and cosine 0 equals to 1, so we have 1 plus 1, which is equals to 2, multiplied by limit sine x over x. You have to use this rule, sine mx over an x equals m over 1. So the coefficient of x up divided by coefficient of x down, and the coefficient here is 1 in numerator and 1 in denominator, so it will be 1 over 1. So the limit equals to negative 1. For part B, you have to find the limit of 2 minus cosine 5x minus cosine 7x divided by 8x when x goes to 0. And to find that, you have to write 2 as 1 plus 1. So the limit will be 1 plus 1 minus cosine 5x minus cosine 7x divided by 8x when x goes to 0. Now you have to group some terms. So you have to group 1 with negative cosine 5x, So we have limit 1 minus cosine 5x. Then you have to group 1 with minus cosine 7x. So we have a plus 1 minus cosine 7x divided by 8x when x goes to 0. Now we have 1 minus cosine 5x and 1 minus cosine 7x. You have to separate these limits, but pay attention, when you separate two limits you have to do direct substitution to check that each limit must be 0 over 0. So we can distribute 8x for the first quantity and for the second quantity, and you will get limit of 1 minus cosine 5x divided by 8x when x goes to 0 plus limit of 1 minus cosine 7x divided by 8x when x goes to 0. Now for the first limit, if you do the direct substitution, you will get 0 over 0, and for the second one also we have 0 over 0. Now since we have 1 minus cosine 5x in the first limit and 1 minus cosine 7x in the second one, you have to use the conjugate. So the conjugate of 1 minus cosine 5x, sorry, here we have 5x, is 1 plus 5x. So you have to multiply by 1 plus cosine 5x, up and down, 1 plus cosine 5x. And also for the second one, you have to multiply by the conjugate 1 plus cosine 7x divided by 1 plus cosine 7x. What the answer will be? Limit. If you multiply 1 minus cosine 5x by 1 plus cosine 5x by its conjugate, you will get 1 minus cosine squared 5x, and totally you will get sine squared 5x. So for the first one we have sine squared 5x in numerator, and in the denominator we have 8x multiplied by 1 plus cosine 5x plus, for the second limit we will do the same thing. We have 1 minus cosine 7x multiplied by its conjugate 1 plus cosine 7x. So 1 plus cosine 7x multiplied by 1 minus 7x equals 1 minus cosine squared 7x, which is equals totally sine squared 7x. So a numerator of the second limit will be sine squared of 7x divided by 8x multiplied by 1 plus cosine 7x when x goes to 0. What is the next step? You have to separate the limit like this. We have limit sine 5x divided by 8x. Now sine squared means sine times sine multiplied by limit of sine 5x divided by 1 plus cosine 5x when x goes to 0, when x goes to 0, plus the second limit. We have the same thing. You have to split the limit. So sine square 7x, you can write it sine 7x divided by 8x multiplied by limit sine 7x over 1 plus cosine 7x when x goes to 0. Now here for the first limit, we have limit sine 5x over 8x, which is 5 over 8 multiplied by, here you have to use the direct substitution, sine of 0 equals 0 and 1 plus cosine 0 equals to 1. So we have 0 over 1 plus, for the second limit, the first one will be sine 7x over 8x. So the answer is 7 over 8 multiplied by, here you have to use the direct substitution, so it will be sine 0 over 1 plus cosine 0, and you will get 0 over 1. So we have 0 plus 0, which is 0. So the final answer of this limit equal to 0. In part C, we have limit 2 minus cosine mx minus cosine nx divided by kx squared. M, n, and k are constants. So this part is like part B, but we have different thing. Denominator is x squared, not x. So with the same manner, you have to rewrite 2 as 1 plus 1. And then you have to group the terms. So it will be 1 with minus cosine mx. So we have 1 minus cosine mx divided by kx squared. I will split the limits directly, plus limit 1, the second one, minus cosine nx divided by kx squared when x goes to 0. For the first and the second limit, you have to multiply by the conjugate. And remember, if you split any limit, okay, you have to check that each limit must be 0 over 0 by direct substitution. Here you have to use the conjugate technique, so you have to multiply by 1 plus cosine mx up and down multiplied by 1 plus cosine mx. Also for the second one, you have to do the same thing, so we have 1 plus cosine mx multiplied by 1 plus cosine mx. Next, everything is here. 1 plus cosine mx times its conjugate equals 1 minus cosine squared mx, which is equals totally sine squared mx. So the first limit is limit sine squared mx divided by kx squared multiplied by 1 plus cosine mx plus limit, with the same manner, 1 plus cosine nx multiplied by 1 minus cosine nx equals 1 minus cosine squared nx, and this gives us sine squared nx. So in numerator for the second limit, we have sine squared nx divided by kx squared multiplied by 1 plus cosine nx. Next, you have to split the limit. So we have limit sine squared divided by x squared, or kx squared. So we can write it as 1 over k, because k is a constant, multiplied by sine mx over x all squared multiplied by 1 over plus 1 plus cosine mx when x goes to 0. This is the first limit. With the same procedure, limit 1 over k sine nx divided by x squared multiplied by 1 over 1 plus cosine nx when x goes to 0. Now for the first limit, we have 1 over k multiplied by sine mx over x. It means mx over 1x, so the limit will be m over 1 squared multiplied by, here you have to use the direct substitution, and you will get 1 over 1 plus cosine 0, so we have 1 over 2 plus, for the second limit we have 1 over k, and we have n over 1 multiplied by 1 over 2. So the answer will be m squared over 2k plus n squared over 2k. Since we have the same denominators, you can find the addition of these two fractions, and you will get m squared plus n squared divided by 2k. So this is the answer of our limit. For part D, we have cosine ax minus cosine bx divided by cx squared when x goes to 0. We have a trigonometric identity of difference between two cosines. Cosine A minus cosine B equals negative 2 sine addition divided by 2 sine subtraction divided by 2. So we will use directly the trigonometric identity, and you will get limit negative 2 sine the sum, which is ax plus bx divided by 2 sine of difference ax minus bx divided by 2 all divided by cx squared when x goes to 0. Now what is the next step? You have to simplify the numerator. First you have negative 2, you can put it out of limit, and you will get negative 2 times limit of, for the first one ax plus bx, you can take x as greatest common factor, so you will get a plus b over 2 multiplied by x. So we have sine a plus b over 2 multiplied by x. Remember that a and b are constants, so a plus b over 2, this term will be a constant. For the second one also, you can take x as greatest common factor, and you will get a minus b over 2 multiplied by x. So we have a minus b divided by 2 multiplied by x divided by cx squared. Now what about c? C is a constant, so you can put it out of limit when x goes to 0. The next step is to separate the limit. Now we have minus 2 over c multiplied by limit sine a plus b over 2 multiplied by x divided by x multiplied by limit sine a minus b over 2 multiplied by x divided by x when x goes to 0. And as you know, limit sine mx over nx when x goes to 0 equals m over n. So you have to use this rule for these two limits. Then we will get the final answer, minus 2 over c. The first limit will be a plus b over 2. This is the coefficient of x up, divided by the coefficient of x down, which is 1, times the coefficient of x up. So we have a minus b over 2 divided by the coefficient of x down. So we have minus 2 over c multiplied by a plus b times a minus b divided by 4. Now you can simplify. Divide by 2, negative 1, divide by 2 equals 2. And remember that a plus b times a minus b equals the difference between two squares, which is a square minus b square. So we have minus 1 multiplied by a square minus b squared divided by 2c. And the final answer, when you enter the negative 1 inside the bracket, you will get b squared minus a squared divided by 2c. So this is the final answer of our limit. In part E, you have to find limit square root of 1 minus x minus cosine 3x over 5x when x goes to 0. And the best way to do that is to multiply by the conjugate, square root of 1 minus x plus cosine 3x divided by square root of 1 minus x plus cosine 3x. As you know, if you multiply a minus b by its conjugate, a plus b, the answer would be the difference between two squares, a square minus b square. This is a in our question and this is b. So the numerator will be the first term square minus the second term squared, divided by 5x multiplied by square root of 1 minus x plus cosine 3x when x goes to 0. By simplifying, can cancel power 2 with the radical, and you will get limit 1 minus x minus cosine squared 3x divided by 5x multiplied by square root of 1 minus x plus cosine 3x when x goes to 0. Now you have to group some terms. You can group 1 minus cosine squared 3x, and 1 minus cosine squared 3x equals to sine squared 3x. So the limit will be sine squared of 3x minus x divided by 5x multiplied by the conjugate 1 minus x plus cosine 3x when x goes to 0. Now you have to split. You have to make separation in this limit, but pay attention when you separate. You have to check that each limit must be 0 over 0 by direct substitution. So we can split this limit as limit of sine squared 3x over 5x multiplied by the conjugate 1 minus x plus cosine 3x. Then we have minus limit negative x over 5x multiplied by square root of 1 minus x plus cosine 3x. X goes to 0. Now for the first limit, we have sine squared, so we can write limit sine 3x over 5x multiplied by limit sine 3x over square root of 1 minus x plus cosine 3x. When x goes to 0, x goes to 0. Now for the second limit, you can cancel x with x, and by direct substitution you will get minus minus plus. We have minus here and minus here. Numerator we have 1 over 5 multiplied by, you have to use the direct substitution and you have to replace x in this function. So we have square root of 1 minus 0, which is 1, plus cosine 0, 1. So we have 1 over 10 for the second limit. For the first one, you have 3 over 5 multiplied by, here you have to use the direct substitution. So we have 0 over square root of 1 plus 0 is 1 plus 1 plus 1 over 10. This term will be 0 and the answer will be 1 over 10. So 1 over 10 is the answer of our limit. And that's it. Thank you.